Hello and welcome to the episode 7 of OpenTTD Code Deep Dive. In the last episodes, we finished up with loading the drivers for sound and music and basically setting up the sound. So the next step would be to generate world, and we will just focus on this today. If you find presented content useful, don't forget to press like button and subscribe. And so the debugging session is already started. I will just deep dive into it. So generate word accepts some kind of mode here. And we can just indicate what kind of map we generate. So whether it's random or just a new or empty. And I believe for the start, we just generate empty of size 64 by 64. And first there's some check of model progress, which is false. And then we have some global general info structure. And I think it just tells us what's the current map. So there's like single map at the most. So we just init that. And then we said that there is some model progress. So we just enable this. And there's this local company controlled by the human player, this client. Okay. I think it's at the moment, it's just some default one, as we haven't started the game really, like no scenarios started. And then there's like company spectator. So the client is spectating. Okay, so when we start the game, it just shows some welcome screen with something happening in the background, and we're just looking at this. So probably it's just how it is. The spectator company. Let's see how we set the local company in general. So there are some validation checks in the beginning. You can go to the next line. Okay, we just tell if we are switching the company. Yeah, okay, we do. Because there was some company 0, which was probably none. And we just invalidate the window data, I guess, in this case. Invalidate window data. All right, we don't have any windows, so nothing happens here. Local company. Okay, the current company is local company. What's the difference between these two? So company currently doing an action, and the local company and is the company controlled by human. All right, so there could be many companies. Some are probably computer player companies. Okay. So now we have only one company, and we invalidate some window classes. Again, we don't have any windows, so nothing happens here. So, and here is the same. And also no windows really, so okay, skip that. Mark whole screen dirty. So add dirty block. We had the setup of windows in the previous episodes. So it basically just gives us the whole invalid triangle. So let's see. Okay, so the whole screen is marked as the invalid region, and all the blocks will be to be filled. And again, the Windows classes. Again, we don't have any classes Windows yet, so we can just skip that. Reset vehicle color map. That's something else, but I don't think we really have the vehicles here. begin. Yeah, it's null. So no vehicles really for the local company setup. And then there's initialized game. So we have the size of the world. On init window system. Make sure that there isn't any window that can influence anything related to the new game. Unshow critical error. Okay, so we just get rid of whatever was there. However, I don't believe we have any window. It's probably null. Oh, okay, it's probably not null. No, it's not, sorry. It's, yeah, here we have the value. Yeah, so no error messages. No windows. Delete closed windows again. No closed windows. Okay. All windows empty. And then we have map allocate. So the map here, size related data of the map. So we have iterator, logarithmic size of the map, number of tiles, some tile mask, land count, such things. And when we do allocate, so this is static thing. So there's a check of some maximum minimal map size, which is like 64 and 4096. So just checks if we are not going out of bounds, and also something some values are not correct, like 64 and 128 are correct, but this tells us that for example 76 is not. Right, so find first bit. I think we have seen that, but basically it just tells us which is the first bit that's being set, and that gives us the logarithmic size of the map. So 6, yeah, that matches. And then the tile mask is actually the whole map. Here we create the tile base as the base tiles. What's the tile here? RAPL class to abstract away the way the tiles are stored. Okay, so the way that the game is done is that the map is divided by tiles, and we just have the unique pointer to the array. Actually, we just allocate many tile bases structures, and tells us what's the height and what's the type of the tile. And by default, we do the allocation like for each tile in the map, and then there's some tile extended, which is some kind of extensions. We'll learn later what it is. Allocate water regions. And what's the water region by default? So it gives us the size, which is basically our global structure size X. And then the water region edge length is 16. So we'll have 64, 16. So it's 4 by 4. So we have like 16 regions. Okay, so maybe it kind of has to tell first how many water is there on the map, and there are some defaults, or there's some rule how to allocate that. So this is water region data. Okay, it tells something about traversability. Okay, anyway, it's like for each region we have one allocation. And some valid validation structure. Type index container. Let's have a look what it is. So it's declared, it's kind of a templated thing. So there's a vector of type Boolean type, and then there's water region index, which is actually strong type, and this is container. Okay, let's try to disassemble it bit by bit. So vector is vector, that should be clear. Water region index is strong type def, and this is some typed thing. It accepts templated parameters. So here is integer, there is some structure, and this looks like yet another structure that just contains another structure inside, some mixing structure, which is actually a templated thing. And this one, this kind of structure also accepts like two templated types. So T-type and T-base type. And here we see, in this example, we have like a bunch of operators. And for example, we can compare this object of this type to object of this type. And it's assumed that this type has the value property, and then we can just compare this value property into the into this second type directly, or in case of this operator, just directly these types can be compared by the value. Okay, so what's the type def here? Okay, so this is kind of class. Sorry, the structure. This is actually a class, it's structure. And it's templated by these three things that we say. And actually, okay, the last property can be the last templated property can be the variable type. So there can be many of these specified. I think in this particular example there's only one, but here actually in the second one, so water region patch label, we have 3 of them, 4 of them. And we saw the compare. The integer is yet another structure that also declares mixin. It's just that there are different operations, so different operators in this case. So we can just increment. We can increment a specific type here and do other operations. So if you go to type def, we see that this inherits actually from, like, okay, the properties are not really here. I don't see anything particularly interesting. Some friend declarations and maybe quality assignment operators. And then we just inherit from this mixin structures that we saw from the compare and the integer, which means, and well, there's like multiple inheritance. So we can actually, if we have multiple types here, then we can inherit from multiple mixins here. And then we say that since these mixins we saw here accept 2 kind of parameters, like template parameters, then in this case we pass the type def and the t-base type. So for example, here we had like an integer as the first type, and then here we have the type def. Oh, here's even, I think, some example usage like integer, and then this is based on the first type, the t tag, the properties. So actually the type def, so this actually this particular type. So it means that this type can be compared in a sense that the value here is stored. Actually, so this value is, okay, it's here, so the protected. So we can store this this base type here. So for example, integer, and then we can actually use this one, tWaterReader index tag structure, which I don't know, I cannot actually jump into it. But I assume this will just contain the value inside, and then we can run the compare operation because we inherit this the mixin declared in the compare. Or we can do actually all these incremental things here on this particular type. So this kind of type, the variables of this type, allow us to run some kind of a trait, kind of the operation defined in this compare actually mixin, integer mixin structures, and we can just do some operations between these two types. Okay, so that's actually now clear. So we'll get back to allocate water regions, and let's see, just outputs what was allocated, and for 4x4 regions, and that's that for map allocation. And then there's a pause mode and game speed, which is probably some global variables here. 0 is infinite, 100 is 1x, right? And pause mode, which is actually one of the 8 variable, one out of 8 enumeration values. Save, load, join, error, active client. All right, so different kinds of pauses. So probably it's like a reason for why the game is paused, and here it's empty. And then we have a timer game tick, which just represents the tick in the game. So we have type declaration and some period declaration, and then we have tick counter here, which is some, okay, yeah, it's like a static value. As like a global timer tick, and it's like zeroed here. And then we have timer game economy, which just says, all right, so what's the time in the game? So year, month, and so on. So again, strong type. We saw that. Year tag. Yeah, why can I see that actually? I can't. Okay, we'll get back to it later probably. Current tile index again. So every tile can have an index, that makes sense, and probably just has to have some default one. THD, tile highlight data. So in this game, when you move cursor over the tile, you can just get it highlighted. Maybe it's somehow related. In the case, it's set to invalid type because we haven't highlighted anything, I guess. And then we have reset of the settings. So for example, here is some script config AI. See, that seems to be reset. Okay. Oh yeah, and we're meant to actually look into the container, so we have like type index container, and then it was also typed in the sense that we can declare the class we'll inherit from, and then we just declare all the different methods of this particular type. So for example, this could be a vector, and then we can kind of get the index as a kind of a type, which is probably stored here. For example, we can reference the container, but by some kind of base. So it seems like this index is some special type of what we were expecting. So the type must have a suitable base method and therefore must inherently match convertible through base. And then we can get like references to the items in the container. So it's kind of a way to inherit from, for example, vector in some easy way. So just this templated class allows us to still use a vector, but in the sense that it's we just allow some extra indexes and just makes things a bit easier. We don't have to declare the template for each vector. Like we don't have to declare the class definition for each vector that stores specific type of values inside. Okay, it seems like we can have some kind of a max companies, like 16, I guess so. And for each there's like a script config. It's being reset here. Okay, so we don't need to be there. And then we have like the settings game. I can go through, and then we have new GFR profilers. This is empty, so skip that. Reset date, and there is some in the settings. We have some starting year. Can we actually look at this? Let's try. Can I read that? Oh, not really. It's not cool, but let's try to just look into this. Okay, so here's our year and month and day. So again, this is this strong type. Again, I don't know what this year tag is. Year tag T. Okay, let's have a look here. So as we see, this is the strong type, or type def actually that inherits from the strong type mixin. So in this case, compare an integer, and here's the value 0 for the year. And then we also have a month and the day. But this is just like this. Oh, because this is just an integer. Okay, that's it's surprising, but okay. Convert year, month, date to date. Okay, here for each month we have like accumulation of days from the beginning of the year, and so we just get the days from the number of days from the start of the year. And if there's a leap year, then there is some correction. And this one, that's actually a function. Yeah. It's actually the function. So we can get the base of the year. Okay, interesting. So what was the base here? It's not the value. Oh, okay, it's the value. It's the way how to obtain the value. So base and value is the same for type div. Okay, so year is an integer. And then we just calculate number of leap years and then just construct the date out of the numbers. So it's like, okay, there are all zeros, so the values will be not quite quite informative because this is just like some default date. You can see nothing really special here. And in the case, we just set this date type 0 here, and then year, month, date is set up here. So that's also kind of interesting. So first date of the first month and the year 0. Just the way to store the date. Now the game economy, we check if we use wall clock units. Timekeeping units, wall clock. It's not a new game. It's interesting. Why it's not a new game? Huh. Okay, anyway, so we will see. Okay, it's not using wall clock units. So we just set the base for the economy. And again, okay, some just global fit setup, just just similar as before, and then some initialize old names, which is what I'm not really sure what old name is. Is it some legacy stuff? Number of old strings, and then it's quite a lot of things to initialize too. Link graph schedule. Let's learn what it is. What's the link graph schedule? Some graph list, some job list. Create all link graphs and jobs from the schedule. Okay, so if we talk about the game where we just like a economy game, like strategic one, I would imagine that there is some like queue with like sort of a job system where you just put some stuff to be done and it's kind of managed. But well, this is just my guess. And there's no job really, which is what I would expect. But okay, we have something like this. And then we have the pool base clean. Base class for base of all pools. All right, so we can have some pool of objects, and it's apparently it can be just cleared. We have some default value, and that's that. Rebuild station KD3. Okay, again, we don't have a stations. So I wouldn't expect anything to be really happening here. KD3 from station ID, KD station XY function. K-dimensional tree specialized for 2-dimensional space. Okay, so this is index to existing data. Using Manhattan distances. Nice. So I would expect this is empty. So we just have, so for this, so we have some nodes here, which is just says which element stored at the node and the indexes of the nodes, left, right. free list, unbalanced. Okay, it's empty. So nothing will be happening here, but we just see that for each station, town, and viewport, we probably just will have the same thing. Yeah, we reserved the items, but it's empty. Everything is empty here. So nothing will happen here. We just iterate through all these things that do not exist. So just skip that. Reset persistent new graph data. Engine manager. Engine override manager. Stores the mapping of the engine ID to the internal ID of new GRFS. Okay, so some kind of mapping between how our vehicles are managed and the houses, industries, and so on. Oh, this is quite big, but it's also quite empty. In a sense that, yeah, it's empty, it's just zero. So, and we fill it with entity ID mapping, the default one. The ID of the file the entity belongs to. All right, so I would assume it just puts everything to 0. Offset mappings, everything to 0. And so would be here. Yeah, and so would be here. Nothing here. Oh, okay. Just a reset. Initialized sound. I think we've been here. Open bank file. I still don't have the sounds enabled. I need to work on that. So here I have a null set, so I don't think anything will happen. No, okay. What's that? Yeah, it's totally empty. So here nothing will really happen. Should really happen. Yeah, it's fine and it's empty. But then I would assume that we have a real file. Do we just open here? And so the sound will be the music will be prepared for. Or sorry, it's actually sound. So music is a separate thing. So so the sounds will be enabled somehow or prepared to be played. And here similarly, we have a set, but this is like a null set. So, but we see that there's some notion of the playlist, and then we can clear. It's been cleared. And here for maximum 30 songs, we just get an entry. But I think it's not valid somehow. Yeah, probably because we have this music set here, which is basically the null set. And yeah, and the song name is empty, so it's not valid. So nothing will happen here. And here, setting style music custom to the order of the second custom playlist, the order of the first custom playlist. It's not really set up, so nothing will happen here. All right, so that was the sound. And then we have the vehicles. Vehicles to auto-replaced. Why do we want to auto-replace vehicles? Auto-replace map. So there's this concept in the game that you can, if the vehicles get old, you can replace them. And there's also you can check that under such option that you want the auto replacement. So game just takes care of that. So it's probably about this scenario, and we don't have vehicles here. So, but we see that there is some RI for the vehicles. Total tile hash size. Why is the hash? Some lookup, kind of a lookup structure. It just sounds like this. So that was just vehicles, init news, items, structures. Yeah, so the game gives you some news, like some pop-ups, kind of like a newspaper, and then the different options of how to show that, what should be shown or what's not. And then we have landscape. Yeah, okay, so we have some sort of edges here. And what do? We have the tile. And this clear grass is just kind of a how we clear the ground. You create a tile index, which is this our strong type, basically. So right, so tile index actually, so okay, we in this function we just use x and y, like two parameters, just to indicate the coordinates, but then the tile index actually stores the flat kind of flat coordinate. So far as like the row, so we know how many tiles are available in the x-axis, and then we just use that to just select the row, and actually to offset by the number of tiles in the row, to offset the y value which is passed, and then we just add the x. And then we use the tile, which just contains this index. And okay, and it was invoked indirectly because make clear requires tile. And so we check set the tile type. That's interesting that we check that the tile is less than the map size. So so just to make sure that the index is not out of bounds. And then there's also this type, which is clear. Is inner tile. Yeah, I would expect this will just give us if we don't go out of bounds. So a lot of checks like this, that's the wise thing to do, definitely. Just to check if we don't accidentally go out of bounds. And then we have this. It sounds like a macro bitmap SB. Set n bits in x starting at bit S to D. Oh, all right. Base tiles, okay. So we get the type, and then we just take, so we get an X, like here, just our integer, and then it says that the start position of new bits is divided by S, so starting from bit 4, and then 4 bits should be set to be set into this value, right? So we for example say, okay, so bit 1 shift by 4, and then just set it up into X. And here, this is number of bits actually. So 1 minus 1. Okay, too many like negations and shifting. So yeah, so we shift the number of bits we want to set up, and then we subtract 1, so we get all ones. And then do we revert that first? No, and then we shift it again by s, so the number of bits, like to move to the start position of the new bits. And then we revert that. So we get just the 1 bit setup, I believe. Okay, in this case, yeah, so here the x is 0 actually, n is 4, s is 4, and D is mp clear. So here doesn't change the x, and here is the same. It doesn't seem like the x has changed. Maybe because mp clear is 0. Yeah, it's just 0. So if it's 0, then well, nothing. Not the best example to show how it works. But it just seems that if tile has a type here, so bits 4 and 7 is a type, then bridges to 3, rainforest does a 0, 1. Yeah, so we just store the type like this 4 bits. That's how it sounds. Okay, and then there is this flags, and we just set them to 0, and then also the owner. So the owner is actually okay. So I think I'm getting it now that the tile is like highly compressed thing. It's just that it's a kind of a bit field, and like this game tries to squeeze as much information as possible into this field. So and like on each bit there's different kind of information stored. So here only like 5 bits are used for the owner. It's like first 5 bits in this particular field, and this is just pushed into this M1 field. So instead of using the whole byte, we just use 5 bits, and the rest of the 3 bits are used for something else. Okay, that's interesting. So why do we do that? So am I missing something? So it's apparently just we shift 0, and then we shift again 0, and we just OR that. Why is it done this way? Okay, I cannot really tell. It doesn't make sense at the first glance, but maybe there's some edge case which I don't see. And here we have also ground density. Okay, so probably this was done because of some pattern. So previously I was saying that when we set the tile owner, we just set the M1 first 5 bits, and here we also do something 5 bits, and then we have like a 2 bits. Maybe it's just a way of expressing how it's actually encoded, so that we say, okay, the 5th bit will be set to 0. and then the second bit is set to type, and even if it's 0 like here, right, it's a clear grass, so it's not necessarily 0. Can I see that here? Clear grass. Yeah, that was clever. And then we also have the density, which kind of is added to this mask. And that's that. And okay, so it's not like a second bit, it's like a we shift by 2 bits, right? So if this is 1, then it's like a third bit. Because then like bits are indexed from 0 as here as well. Okay, so this is like the logic for clearing the tile apparently. And then we set the tile height, and this is 0 for everything. And then tropic zone is like normal. I think tropical zone is not in there every map. And then we can clear bridge. Clear single bridge middle. Clear bit. So we take the type. Okay, each axis. This is probably 0 and 1. That's right. And then we clear the bit here. Yeah. Okay. So we just revert the bit, like we take the bit on this Y position, and then we revert that, and then we just clear the rest from this X, because we just DM. So we are just left with this one bit if it's set up, or anything that's bigger than this. Yeah. Okay, and this happens for all the freeform edges here, or actually to the max X, which is like 64. So let's keep this one, and then we just make the void for all rows and for all columns apparently. So X is variable here, and here's max Y. So it's like right. So okay. So for all tiles which have like a maximum value here, so on the last tile, or the last row of the tiles, or last column tiles, we just do this make void. And what's that? Is it some kind of a special type maybe? I would guess so. Yeah, so there's a special type MP void. Invisible tiles at the southwest and southeast border. Then we can see this type is something else. 0, 1, 2, 3, 4, 5, 6, 7. Right, so the value is 7, so we just set it up on the tile. I'm just wondering, okay, so here the value is base tiles. So okay, so as you see, the tile has the reference, by the way. So the tile has the reference to the static array of tile bases, and then there are many tile objects, and we just use the base to just reference the base tiles here, this tile base, and then here's the type. Yeah, and this type is then used to just to set up. Oh, here it goes. Yeah, so this was like shifted, and then we have the correct value. set up on X for the MP void type. And here it's for the tile height, we just get 0, 0, and 0 for everything else. Probably it's just ignored. All right, so that's the landscape. And then the next thing is the rail UI. Okay, so some default how we build the depot direction. And then selected class for the station. Default station class, waypoint class. Interesting, because there's like one type of station class and the waypoint class. Okay, why is it here? No idea. All right, that we'll see later. And then for road. Okay, the road again. So there is like some direction. So okay, when you build the game in this game, the road or rail roads, actually they can be this can be built in 4 directions. So, and when you open the build menu, then there's probably some default that or actually the last selected value. So it just initialized to some defaults here, and this is basically that. The same for airports. APC begin, lowest value at airport. Okay, so the one that ID for helicopters, so we can have a big airport, small airports, the helicopter airport, and then dock UI, ship depot direction. Oh, it's probably the dock, like the ship dock. So when you create the place where you create the ships or build the ships. And graph UI. So there are some statistics in the game showing you how many cargo you transported, and you can just exclude some companies, compare, like, you know, rank your companies against the other companies. Object UI. Object picker. Yeah, interesting. I'm not really sure what this object picker is. I mean, you can just select the object, like with an arrow, but and apparently there are no more options to select. So town local authority tree, KD tree. So for towns, we also can have like this indexing tree. And then script UI. Script debug company. Invalid. Okay, we set up some default scripts to invalid. Maybe they are set up later. Initialized trees. Yes, so we have like green fields in the game. And there is some tick for the trees. Yeah, okay. So there are trees in the game in the sense that there are some of them by default, but also when you reorganize the terrain, for example, you flatten the terrain with some modification tool, then you just get with the like a bare soil, and then small trees are just popping up, and then the big trees. So probably it's just controlled by some ticker. And then we have an industries, and by default it's, yeah, let me guess, it's empty. No, it's not. Okay, no, it's not empty, but it's like a kind of static array of empty stuff. Yeah, now industry types. So you can have like 240 types of industries, but they're just not initialized yet, like with some meaningful values. Industry builder. total number of industries. And we can just reset that. Okay. So some structures to control the industries. So industries are in general static. So it's just at the beginning of the game, they're kind of randomly generated. But then during the game, some of them can collapse or can just pop up the new ones. These are kind of rare events, but this happens. So probably this was what was controlling that. Reset type counts. Okay, so we have okay, number of supported objects. So it seems like we have some overall pool of 64,000 objects. And just being filled with 0. Or maybe just like a counter for each type of them, maybe 64,000 of types. Okay, we are nearly there. Initialize companies. Current company tick index. Okay, so we can define how many companies we start with. I mean, it's like a player company, but there are some also other players, like AI players as well. And we can also define how many of them will pop up during the game. Okay, do we have scanner info? No. Frame counter. Oh, and we can do the scanning here. And then we can initialize that. Script scanner. Squirrel. What was the squirrel? I think okay, it was the scripting thing. Right, so this is something that will run our scripts, as I would assume. And this will just sort of scan maybe for the scripts and then reset, but this was squirrel. Yeah, so full reset of the scripts. And I believe that this was some external thing, so third party, yes. Okay, so I would assume, yeah, it's just external library. I will not deep dive into this one. We'll just use it as it is, or actually review as it is. Main script dummy and script create dummy info. So just probably for initialization. Yeah, virtual machine. Okay, maybe we can just have a look how this looks like. So there is some dummy class, extends info. Then we have a functions. Like get time, get author, get date. And then we say register dummy, and that's that. I'm not familiar with the squirrel, to be honest. So we'll kind of learn while just moving on what it can do. And here there's some scanner library, I believe. Similar thing. And then, okay, game initialize. So we initialize the objects. And here we just scanner for the game mode. What does it mean that there's a game mode? Scan for game scripts. Right. Initialize cheats. Okay, so interesting. We can cheat in this game. All the cheats. We can see how to cheat now. Magic bulldozer. Switch company, money. Everything is here, so you see. So structure folder cheats. And then this can be enabled probably if it's activated or and it was ever used. It's nice. Init text effects. Right, so we can have some effect for some duration of time. Make the text effect slowly go upwards. Keep the text effect static. Okay, so for example, if you, in this game, you can have the situation that you earn the money, like your, let's say your train earns money, and then you see like the small text with the money appearing near the engine, for example, and then it goes slowly up and then disappears. So maybe this is what the effect is about. Network init chat message. Right, so this is some kind of a chat message in the multiplayer game probably. We'll not focus on the multiplayer soon, so I would just skip the details. Animated tiles. Yeah, some tiles can be animated in the sense that, for example, the water can be animated, or maybe some kind of forest with some animals. I think these were animals, or even buildings, like some tall buildings have the lights on top of them so that the planes won't hit that. So maybe that's that. And here we have like the economy initialization. Clear cargo monitoring. Okay, but the company is still invalid owner. And all these maps are empty. Cargo deliveries. Map of monitor deliveries to the amount since last query activation. I'm not really sure what this map could be about. So let's see later. And then we have reset object to place. And we can have like set object to place 0, which is cursor mouse, palette none, HT none, highlights type none, some defaults like main window. Okay. So we have a window and then we say it's invalid. Set tile select size. Highlight tiles at the cursor. So at the top left, we just select highlight the tiles, and width of the highlighted tiles rectangle, is it? Because the tile size here is like 16, like about 16 pixels. Tile size in the word coordinates. All right. So 16 units, it's like 16 items in the word coordinates. Make square red. Special mouse mode. None. No special mode. Okay, so nothing happens to the mouse. Place mode. Okay, we've seen that. Yeah, highlight style, nothing. Window class. Okay, nothing special. Set mouse cursor icon 0. So just default 1. Sprite. Clear the sprites for the cursor and then just leave the default 1. update cursor size. No, okay. Ignore setting any cursor before the sprites are loaded. All right. So still sprites ahead. And then we have like a game log. So this is some new structure, game log. We see that's the class of some action types, logged actions, and so on. And then we just reset that, which is for internal data, we just clear that. And then we have the start action, game created. Okay, at some point it still accepts this type, but okay, it has the action type here actually in the log. So we log only when the state is like the same as the game at none, and then we just say okay, so we start. Oh, okay. Does it print anything here? Not really. So this was the scanner output probably, but nothing else here. Revision. Okay, we just check that the game is started or loaded. And then what happens here? We just run the change. Get game log revision string. It's not the released version. So we just get the format of this OpenTTD revision hash. We just like the hash of the Git repository. And logged change revision, we just create that. And we should have this change here. Okay, so just the structure of the specific type. Like this. And we see like change game revision string, added graph, loading compatible graph. So kind of a very low level actions, I guess. And we just set up what's the correct action, current action in the game log. And then we just when did it happen? Okay. I think that's that. And then similar for mode. We see something very similar, I guess. Since there is already the current action, so we just take this vector here, and then we just have yet another change, which is setting up the mode. And then we add the graph config. But there's nothing inside. And then some stop action. Oh, it's the print here. Yeah, it's print. And print debug 5. Well, whatever. Print debug. Prints game log to debug output. Okay, should we expect something here? So we have this kind of lambda. Can I see that actually? Oh, I couldn't see that. But you see, it just logs things here. So it just calls the standard debug on this game log level. And we have the string here. So so game log start in this case. And then we have all these actions. Okay, actually the one action, game log internal data. So we have one logged action. And then we just debug that, and we just log when it happens. And there's also the text which says what the enum was about. And that should just give us that at tick 0, the new game was started. And then there was also we have like two changes. And we can call format on that. And because this was like a revision change, then it says, okay, so the revision was changed to this particular thing. And then we have this message here. So we should see that revision text changed. And we have our hash of the revision. And then there was like a new game mode and landscape, and then game log ends. So it was basically, it seems like this game log works like this, that you can set about various things, and then you just, after you stop recording, you can just get all the logs dumped into the terminal. Okay, so what's still left? We just initialized the game, and then there's still some things I get, like prepare generate word progress, and loading the sprites, and again the reset Windows system. I think we saw it many times. And then yet some internal generate word. So I think for today that will be all. In the next episode we'll just continue with that and see how much of the word to be generated is still there. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.